Hello, welcome to Designs for the Edge with Microchip Technology. Designs for the Edge is our live stream series in which we talk about fast-growing markets and the technology trends behind them. I'm your host, Eric Glatfelter. We are live streaming today, so be sure to like, subscribe, share as appropriate, and feel free to ask questions. We'll take a look at those and see if we can get to them at the end of the broadcast. Our topic today is technology trends in e-mobility. Joining me in the studio is Joe Thompson. Joe, welcome.
Thank you.
Would you share your roles, I'll say that plural, I know you have a number of different hats, with our viewers today.
So my day job is I'm responsible for the business unit that produces all of our DSPIC digital signal controllers. And so that's what we sell to pay the bills. But about 2 years ago, Microchip looked at the technology market space and said, where are the areas that are going to grow much faster than average? And we created teams for each of those segments. And so I have the fortune to be the executive sponsor for our e-mobility solutions team.
Excellent.
And so I've had lots of opportunities to see all the cool things that are happening in the e-mobility space.
All right, so let's talk e-mobility. Now, that means everything from two-wheelers to 18-wheelers and the infrastructure. I think we'll start out by talking about light vehicles, because that's what most of us equate to e-mobility.
Yeah, and that was one of the first things that we had to determine is what was an EV. And so pretty much it's anything that moves a person electrically.
Yep.
So we're doing scooters, bikes, motorcycles, cars, SUVs, and even now looking at buses, trains, heavy construction equipment, things like that.
Sure.
So it does cover the whole gamut of transportation devices.
Okay, so we've been talking about electric vehicles for years and decades, right? But where are we today? Where are we in today in the near future?
Yeah, today's a little bit tough, right? If you look at, the headlines today, there's a little bit of a lull in the optimism for electric vehicles. So 2 years ago, everything was electric vehicles. The whole world, right? GM, Jaguar, Land Rover, everybody's going to switch to electric vehicles. We're not going to sell any more gasoline vehicles by 2025 to 2030 to 2035. Sales were doubling every couple of years. U.S. committed to $7.5 billion for infrastructure improvements. You saw that Hertz invested in a huge Tesla fleet of electric vehicles for rent. And then if you look at today, all the headlines are pretty much just the opposite, right? And I didn't get to have the Hertz headline here, but they were really unhappy with their Tesla investment. The U.S. manufacturers have all kind of backed off of EVs for a while. They're taking a step back. They're more focused on gasoline combustion engine vehicles again, hybrid vehicles. Germany has decided that biofuels are okay till I think until like 2050. And so the sentiment now is really much more negative than it was 2 years ago.
Okay, and we don't write headlines about individuals, but a couple of years ago there was a lot of hype about it, I think, in individual people being excited for electric vehicles, and maybe that's still there, but it hasn't increased into the general population as quickly?
Yeah, and so, but that's not uncommon for any new technology. So there's a research firm called Gartner that actually has a curve that they developed for how technologies transition over time.
Sure.
And I think that e-mobility is following that same curve. So if you look, there's a peak of inflated expectations. And I think that's where we were 2 years ago. And it's where all the early adopters are early adopting. And as soon as you run out of all of those, now you've got to sell to the general public, and that's a lot harder.
Right.
And so when you run out of the early adopters, you haven't convinced the general public to purchase your new technology, you end up in the trough of disillusionment.
Right.
And I think that's where we're at now.
Okay.
And
So sorry, just to frame this, can you give us some examples of previous technologies and sort of what they went through in the
Yeah, so I was
Peak and
thinking
Valley?
about that yesterday morning, and both of them ended up being about television. But so the first one was, growing up, cable television.
Okay.
Didn't exist, and then did. One of my friends in the neighborhood had it, and we could watch the Cubs on WGN. It was the coolest thing. But you talk to my parents, and it's like, we get over the air for free. Why would we ever pay for cable?
Right, we get 3 whole channels over the air
That's
for free.
4 with Fox. But over time, everybody has cable now,
Yeah.
and it just became part of it. The other one that's been more recent was the transition to HDTV. And in that case, it was really more of the argument of hardware versus content. And again, I had a friend who purchased one of the very first HD TVs. It was rear projection. I think Texas Instruments made it. And he had a big party to come see his HD TV, and we could watch the Discovery Channel because the Discovery Channel was the only one that provided HD content. And so you had everybody wanted to have HD TV, but there was nothing to watch.
Right.
And nobody wanted to make content because there weren't enough TVs. And so you start out with everybody's going to buy this, it's going to be the best thing ever. It was the headliner for the Consumer Electronics Show. And then people bought it, and it's like, well, I can't watch anything. And then gradually over time, content started to come around, and I don't think you can buy a non-HD TV today.
Right.
So I think that e-mobility is going to follow that same path.
Okay, so maybe there's a parallel there with the charging infrastructure and the electric vehicles.
I think that's a great analogy, right? I think it's very much, I'm not going to build a fast charger because there's not enough cars to pay for building it. I'm not going to buy an electric vehicle because there's not a fast charger.
Yep.
And so I think that the U.S. investing in infrastructure will help that.
Okay.
But it's going to take time.
Okay, so what's happening to move us up the slope of enlightenment?
So the question becomes, is it really just a trough and it's a lull, or does it go away? And I truly believe that the technology is viable, right? As an engineer, if I looked and said, if I was going to start a transportation device today, how would I design it?
Right.
The electric vehicle is very close to what I would end up with. And so I think it's the correct technical solution for a lot of reasons. If you look at the gasoline combustion engine and the cars of today, we've got 150 years of gradually adding pieces to the gas engine to make it do new and different things. And so now it's a Rube Goldberg combination of like 2,000 parts to make a power drivetrain. And so, it's things like, I want to have power steering. Well, I'll add a hydraulic pump and attach it to a belt. I want to have air conditioning. So then I have to add a compressor and a belt.
Okay.
And pretty soon you have all these pieces hanging off of the engine. The joke was for a while that if you poured water into the engine compartment, it wouldn't get to the bottom because there's so much stuff in there.
Yeah.
Where with the electric vehicle, we got to start from scratch. And they really got to combine all these capabilities and features in ways that make sense. And so what took 2,000 parts to get from an internal combustion engine, we can do in like 20 today.
Right.
And so it's such a cleaner design.
So that combustion engine went from just driving the vehicle now to also generating a whole bunch of electricity to support all these luxury features and extra features.
Yeah, it's interesting because if you look, the very original car was pretty much all mechanical. I mean, it was the case where even to start the engine, you had to provide a crank. And that was like the first thing we added. Well, let's add a starter motor.
Yeah.
But over time, we've taken almost all those mechanical systems and replaced them with electrical systems. So, the interesting one would be GPS navigation versus paper maps.
Sure.
Power windows, power locks, everything now is electric. And so in some ways, the electric vehicle is really just a logical conclusion.
Yeah.
Right?
Okay.
I finally replaced the engine and the gas tank with an electric motor and a battery, and I've completed the path from full mechanical to full electrical.
Right. So we actually talk a lot at Microchip Technology about automobiles. Internal phrase we use is, they used to be marvels of mechanical engineering, and they still are, but they're now also marvels of electrical engineering and software engineering. So what do you think the EV of the near future looks like?
And so when I was in China last year, I got to ride around with one of our distributors in, I think it was a Li Auto L6. And this is actually from their website showing, their advertisement for the L6. And I think they've done something really clever, right? So this is an extended range electric vehicle, is what they're calling it. And so it has a electric drivetrain, and in full electric mode, it has about 120, 130 mile range. So it's perfectly suitable for driving around town, going to and from the office. But then it also has a gasoline generator. And the gasoline generator, you can enable that where it will charge the battery as you drive. And then your range goes from 120 miles to like 800 miles. And because the gasoline engine is just driving the generator, it can be tuned just for that one function.
Okay.
So it runs at 1 RPM, it has a single load, and it can be very efficient.
Yeah.
And so I think that this is where the industry is going to go. I think Nissan's announced that they're going to go that way. I think Volvo said in Europe that they're going to introduce vehicles like this. And then my holy grail, the end game for all of this would be you replace that gasoline engine with a hydrogen fuel cell someday.
Okay.
That you keep the electric powertrain, but then you use hydrogen to generate the electricity for it.
Yeah.
And so I think once you get to there, we have a fixed range anxiety. The charging infrastructure isn't quite as critical. It's 100% green. It just seems like the solution.
Right.
It's just going to take a little time.
Sure, as with anything. Very interesting. So what are the, from a semiconductor technology standpoint, what are the main buckets of technology that go into e-mobility?
So, and for Microchip, we really do have a very broad portfolio that fits very nicely with the e-mobility space. The main places where you're going to see electronics that are different from what you see in a gasoline vehicle is definitely the electric motors, battery charging, battery management, fast charging systems outside the vehicle. All of those become the new things that you have to design. And Microchip actually has parts that can create those complete systems. So we have microcontrollers, digital signal controllers, we have FPGAs that can do all the control functions.
Sure.
And like you said, software becomes more and more important. I want to be able to change what the vehicle does on a weekly or daily basis. We have a silicon carbide product line. And as a design engineer, I think of high voltage as 5 volts, and I want to measure my electric currents in nanoamps or microamps. Electric vehicles
Not going
are
to cut
in
it for an EV.
kilowatts, megawatts. There's some cases they're 800 volts, 1,000 volts, and so the robustness requirements to manage that kind of energy is really, really complex. And I'm proud that Microchip has a silicon carbide line, and it really is one of the most reliable product lines for silicon carbide in the industry.
Yeah.
We have an analog portfolio, and the reality is that although everything's done in software digitally, all the real world inputs and outputs are still analog in nature. So I'm going to sense a temperature, I'm going to measure a velocity, and I've got to convert that into digital numbers so I can make decisions on it. And so the analog handles all of that. We have those types of things. For an electric motor, one of the key things that you have to be able to do is identify the exact position of the rotor as it's spinning.
Okay.
To be able to control it, you have to know exactly where it is. Traditionally, we've done that with Hall effect sensors. They detect changes in the electric field. They tend to be fairly expensive and relatively delicate. And delicate and automobiles and driving don't necessarily go together. So we have an inductive sensing solution, which does the same thing, but it's a very solid state design, and there's no breakable pieces. And then finally, in the world we live in today, if you're communicating in any way, somebody will try to take advantage of it.
Right.
Whether they're hacking your computer or the computer network, and we're seeing the same thing in cars, right? There's recently been, a case where if I took the front headlight off of a vehicle, I could stick a CAN analyzer on it, and CAN is the communication protocol inside the car, and tell the car that the key is present, and it would unlock itself and let you drive it off. And so, my view is if you have a communication port, you better have at least authentication to say whoever's talking to you should be talking to you. So security is becoming much more important.
Yeah, so I think just 2 weeks ago when Alexis was here, she told a story about somebody hacking into a casino through a fish tank. And it was basically the same thing. They got into access, and it wasn't the fish tank, it was what it was connected to.
No, it was a smart thermometer in the fish tank.
Yeah.
So on your phone, you could see what the temperature of your fish tank was at any time.
Right.
But it was connected to the network.
Everything
it had
else.
no security,
Yeah.
and it provided a path into.
So in this case, the headlight is connected to everything of
Yep.
importance. So how important are the algorithms and the software and the tools in security?
Probably 90% of it. There's a hardware piece of it, so in this case, if you couldn't remove the headlight, or if I could detect when you're removing the headlight, that hardware becomes important.
Okay.
But all the rest of it is software, firmware, libraries, and again, Microchip provides all those for free.
Yep.
So you buy our hardware solution that does the tamper protection, it has some hardware acceleration so things happen faster, and then all the software pieces that make it all work just come with it.
Yeah. Okay, so yeah, there's a bundle of hardware and software and tools and everything. What does Microchip offer to help designers get started or get far down the road on their design?
And this has been probably the most fun that I've got to have in the e-mobility space is that, we've kind of viewed our role is to create reference designs. And so the goal would be for me to give you an onboard charger that gets you 80% of the way there. I don't want to give you a complete solution, because if I give you a complete solution, I'm also giving your competitor a complete solution, and pretty soon we all have the same solution, and it just becomes a price competition. But I want to get you most of the way there so that whatever clever idea you have to differentiate your product is easier to implement. And so we've got onboard charger reference designs, we've got fast charger reference designs, we're doing thermal management in the car, we're doing some audio stuff in the vehicle. So we're taking each of the major pieces of an electric vehicle and creating the base foundation for creating those applications for one of the OEMs or tier ones.
Sure. And in some, you mentioned it includes the software, and in some places there's testing and certification
There is
done,
testing and certification, and then the other thing that Microchip does, which is unique in the industry, is not only will we give you the software, but we'll give you the source code to the software. So, generally, if you get libraries from somebody, they're a binary file, they're protected. That's their key part of, what they're providing. Microchip doesn't really believe in that, and so instead, we will give you the source code so that you can modify it.
Right.
So if I give you source code that says I'm going to communicate through protocol X, and your system is set up for protocol Y, you can modify our code to use protocol Y now.
Okay.
And so having source code is a huge advantage for the end user.
Absolutely. Okay. Lots of tools there to accelerate their designs. All right, Joe, thanks so much. Let's pause there and let me see if there are any questions from the live stream. And I lost my feed for a second. So in the meantime, I know one was submitted beforehand, which was, or early in the program, which was, you mentioned 2-wheelers to 18-wheelers. We have focused on light vehicles, but what's going on a little bit more in, for example, the 2-wheeler market?
Yeah, and we spend as much time on 2-wheelers as we have on 4-wheelers, but time constraints really, prevented me from talking too much about it. We talked about the reference designs, and we have, I think 7 reference designs today, and they range from different power levels of motor control to battery management. A lot of the new 2-wheelers actually will have like an LCD display, with touch on it, so they will have navigation just like you do in your car.
Sure.
But it's got to be weatherized because it's not indoors anymore. And so we provide solutions for that. But we see the two-wheeler market as being at least as big as the four-wheeler market,
Okay.
especially in Asia, where there's so many people and so little space that the two-wheelers make a lot more sense. And I've seen some analysis that says that the potential pollution savings are actually greater if you took the whole two-wheeler market and made it
Right.
electric than if you took the light
The light
light vehicle market and made it electric.
Okay.
So that it is a big focus area for Microchip.
Okay, interesting. Okay, so I'm back online here. So, and our first question is actually on the other end of that. How do you see EV moving past automotive into airplanes, passenger drones, cargo or passenger ships?
So I think the cargo passenger ship one is pretty obvious. I think it's going to go that way. We're looking at solutions for that. There are some companies out there already doing it. I'm not convinced for the whole VTOL, air taxi, drones delivering packages.
Yep.
I'm not convinced yet.
Okay.
I somehow feel like that's a clever solution that needs to find a problem now.
Right, okay.
And so we'll see what happens. It's likely I'll be wrong, and in 10 years from now, we will all expect our packages to come in 2 hours from Amazon via a drone.
Well, I think there's a technology aspect of it, and then there's a business model aspect of it, right?
Yeah, and for anything in the air, there's going to be a whole bunch of regulatory
Sure.
requirements as well.
Sure.
You know, right now, people are leveraging that the FAA doesn't count anything below a certain altitude, and so they're taking advantage of that. But if it gets too messy,
That might change.
They will change it.
Yeah. Okay. Another question from online is, one of the biggest barriers to EV adoption in the US is the substandard charging infrastructure. When and how do you think that gets improved?
Yeah, that one's near and dear to my heart. I went to LA with my wife, and so you have to stop one time to charge. And so it cost me $400 to charge my vehicle because she wouldn't sit in the vehicle while it charged. Therefore, I had to drop her off at a casino. And while I charged it, she lost $400.
Okay.
But I think it's like a lot of things. Like we talked about for HDTV, I think it's going to take longer than we'd like it to, and there's going to be bumps along the way. But as we have more cars, we'll have more charging stations. As we have more charging stations, we'll have more cars, and we'll eventually get to what we have equivalent for gasoline today. I think that Tesla opening up their charging network is going to help all the rest of us a bunch.
Yeah.
And then I think the business model is also flawed for charging stations today, right? If you look at a gas station, you have a person there monitoring it who has a vested interest in it working.
Mm-hmm.
For charging stations, these have tended to be little towers in parking lots that nobody's in charge of. And so when something goes wrong, there's nobody there to fix it.
Mm-hmm.
And so I think that as that model changes and you have some oversight, that the reliability issues will also start to go away.
Sure. Okay. Okay. I don't see any further questions, so I think we'll wrap up there. Joe, thank you again so much for joining us and sharing your perspective on that.
No, thank you for having me. Hopefully you can tell that I'm passionate about the subject.
Absolutely.
And yeah, I like the opportunity to share where I think it's going.
Thanks again. Very
Yep,
interesting
thank
stuff.
you.
To our audience, please visit us at microchip.com to look up information about our automotive and e-mobility solutions. You can find our reference designs there as well. For more information about Designs for the Edge, the live stream series, please visit us at microchip.com/Designs for the Edge. There it is. You can subscribe. You can see our next episodes. We have 3 more episodes in this season. Also, please remember to like, share, and comment on our live stream episode of today as appropriate. Thank you again for joining us, and see you next time.